Okay, welcome back. My name is Adrian May and we're going through a tour of SAT and ACT math, and today we're going to look at a very short video at polynomial roots and factors. So these are kinds of questions you might have seen in both exams where you have quite a squiggly graph, it goes through the x-axis several times and it asks you what a possible definition of this function is. And these questions might look a bit intimidating because they're functions bigger than quadratics, there's loads of intercepts, and we might be unfamiliar with working with graphs of this size. But this question type is actually relatively straightforward. You just need to look at the numbers where it crosses the x-axis, change the sign over, and think about any kind of weird behavior on the graph. Does the graph kind of bounce up on the x-axis? Does it do an S shape? Or does it just cut straight through? So this video is going to explain all you need to do to these questions. Once you know this stuff, they're really straightforward, and that's another aspect of the math section of these tests totally unlocked. So without further ado, let's just get straight on it. Okay, so to begin our discussion of polynomial roots, we're going to start with this function here, which hopefully is recognizable as a parabola. So this is a quadratic. And what we can tell straight away is that we have intercepts at -2 and +3. And so firstly, the function f of x equals x squared minus x minus 6 has x-intercepts at -2 and 3. And this means that the solution to the equation x squared minus x equals 0, the solutions will be -2 and 3. And these are also sometimes called the roots or the zeros of the equation. And so roots, zeros, solutions, x-intercepts are basically the same ways of saying the same thing. And here the solutions are -2 and 3. And as we know from quadratics, that means the factors of this quadratic are x plus 2 and x minus 3. So hopefully from quadratics, we're familiar with the relationship between solutions and factors. If the solutions are -2 and 3, we change the sign for the factors, and the factors are x plus 2 and x minus 3. And this is because we want each pair of brackets to equal 0 with one particular value of x. So if we subbed in -2 for x in the first bracket, we would have -2 plus 2, which does indeed equal 0. And when x is 3, when we sub that into the second bracket, we have 3 minus 3, which equals 0. And so that's what you want from factors of polynomials. We want them to equal 0. And so again, with quadratics, we're used to having two solutions and we're used to factoring them, but then we can also expand this to polynomials of increasingly larger degrees. So for example, if I change this graph and added another intercept here at -4 and another 2 intercepts here at +6 and +8, we now have a polynomial of a 5th degree polynomial with 5 solutions, with 5 roots. But just as quadratics, we can look at the intercepts on the graph. We now have intercepts at -4, -2, 3, 6, and 8. And we can turn these into factors. And so one possible definition of this function would be that f of x equals, and we have our original two factors, x plus 2 and x minus 3. But now we have additional factors of x plus 4, x minus 6 and x minus 8. And so again, we have an intercept at -4, so this becomes the factor x plus 4. We have an intercept at +6, this becomes the factor x minus 6. And an intercept at +8, this becomes x minus 8 as a factor. So we reverse the signs. So let's bring up another example. Here is another function. And so the SAT or ACT might ask you, what is a possible definition of this function? And we can, again, build that up using the zeros to convert into factors. So if you want to pause the video and have a go at this, please write down what you think the factors of this function are. Okay, so let's work through them. So we have an intercept at -9, so that's going to give us the factor x plus 9. We have an intercept at -2, so that's going to give us a factor of x plus 2. We have an intercept at +5, that's going to give us a factor of x minus 5. And we have another intercept at +10, it's going to give us a factor of x minus 10. We also have an intercept at the origin. So our graph goes through the origin. We could call this, if we're going to turn it into a factor, that could be either x plus 0 or x minus 0. That's a slight clumsier way of just saying x. When x is 0, our function also equals 0. So x itself is a factor of this polynomial. And so what we normally do is we just whack an x right here at the start of our chain of factors. And so one possible definition of this function is f of x equals x, open parentheses, x plus 9, x plus 2, x minus 5, and x minus 10. And these questions are super straightforward. We just have to read the intercepts and turn them into factors. They're quite nice questions to do. They often say one possible definition of a function, because this function could also be different in other ways. We could put a 4 at the front of here and the factors would still work. We could put a 5 at the front, whatever. So there are many different definitions this function could be, but this is one possible definition of the function. So that's relatively straightforward. We're just turning the intercepts and the zeros into factors. The other thing we need to be aware of are there are different behaviours of intercepts that we need to be able to recognise. So looking at this next question. Again, we can work through this in the same way. We can build up a list of the zeros and so the factors of this function. We have f of x is going to equal, and we go through the origin. So we're going to have an x at the start. We go through -7, so we have x plus 7. We go through -3, so we have x plus 3. And we go through +6, so we have x minus 6. However, what's different here is we have some strange behaviours. At x minus 7 and at the origin, our graph just goes straight through. They're just normal x-intercepts, so that's fine. But at x minus 3, we have a turning point. Rather than crossing through to the other side of the graph, our graph bounces back up at -3 and curls back round. So what this actually means is we have multiple solutions at this point. Normally we call this having two solutions. So if we have an intercept that doesn't go all the way through, but actually doubles back on itself and turns up, we usually think we have two solutions there. So rather than just x plus 3, we call this x plus 3 squared. We have two solutions at this point. And actually we could have any number of even solutions. This could be x plus 3 to the power 4, 6, 8, 10, and so on. Any even number of solutions at this point would give us a kind of turning point on the x-intercept. So, it could be 2, 4, 6, 8, 10, so on. But usually in the answer choices, it's just 2. That's the kind of most straightforward thing to have, is have two solutions. And so then we need to look at where the intercept at the point x equals 6. And here, rather than a kind of turning point and bouncing back up, we have what's called a point of inflection. Point of inflections tend to have this S shape as a graph goes from either concave to convex or convex to concave. And what that means is we have at least 3 solutions at this point. If you think about the graph y equals x cubed, you have a point of inflection going through the origin. It's that kind of shape. And again, this could be any odd number higher than 3. So it could be 3 solutions, 5 solutions, 7 solutions, 9 solutions, but it's usually just 3. And so above the factor x minus 6, we're going to add a 3. That's going to be x minus 6 cubed. And again, this is one possible definition of this function. Okay, so the two things we just need to look out for. These questions are really straightforward. Where are the intercepts, and are there any strange types of behavior at these intercepts? And so here, one more question. If you want to pause the video and have a go at coming up with one possible definition of this function. And so again, we go through the origin. So we're going to have x at the start of our function. We have x minus 8 is an intercept. So we're going to have x plus 8 as a factor. And we go through +5. So x minus 5 is going to be a factor. So we have the 3 factors there. Because we have a turning point at the origin, we have at least 2 solutions there. So we're going to put x squared at the front of our function. And again, we have a point of inflection when x equals 5. So we're going to have x minus 5 cubed to the power 3. And then we have, therefore, f of x equals x squared, open parentheses, x plus 8, x minus 5 to the power 3. That's one possible definition of this function. And that's it for these type of questions. So as long as you get used to figuring out what the intercepts mean in terms of factors, and then how to think about the behavior of those intercepts, these questions are super, super straightforward from here on in. Okay, thanks for watching. For those of you doing the SAT, I will do another video on polynomial division, which is another really big question that comes up in the SAT. Otherwise, you can now just hit the exam, start doing some practice questions and see where you want to go from there. If you want any further help with any aspect of the SAT or the ACT, be it the writing, reading, science, math, the essay, I can also help you with one-on-one lessons. I'm also a personal tutor, so please do get in touch. My website is below. I'm based in Glasgow and London, but I do a lot of lessons online, so I can help you wherever in the world you are. Also, obviously, if you're finding this useful, please do like and subscribe. If you want to leave any comments below for any of the other videos you want me to make, any questions you have, please do that and I'll get to them as soon as possible. Otherwise, thank you for watching, have a good day, and hopefully I will see you again soon.